Welcome back, and we're going to dive right into that statistics-centric view of the scientific method by looking at formulating theories, and that's where we talk about creating a hypothesis test. Okay, and so from our perspective, a hypothesis is simply just a theory in statistics. Okay, I know when you learned it in maybe high school or something, you said hypothesis is an educated guess. Well, uh, yes, I'm not saying that that's incorrect, but maybe that educated guess is just reworded as a theory. Okay, and then also just know in terms of language, the plural of hypothesis is hypotheses. So when you have two of them, you say hypotheses, and we will be using that language more often than not. Okay, but now when we discuss those theories or those hypotheses in statistics, we discuss two things in every single hypothesis: a population and a parameter. Okay, and when we think about maybe defining these, I'm going to let you fill in your own definitions here, but generally speaking, what a population is it's just the largest collection of individuals you can gather that are relevant to the study of interest. Okay, so if we're, if we're often wanting to in the medical industry test out the efficacy of a certain drug, we would want to gather the appropriate people. You might not want to test all U.S. citizens. You might want to test those with a certain condition, say. So you might need to narrow your population just a little bit. And then consequently, the parameter is the quantity of interest that you're investigating. So oftentimes you could look at response time. You could look at average length or average time. There's different quantities you can compute that are related to this population of interest. Okay, but nevertheless, you compute a parameter based on the population. Okay, now when we once we have a hypothesis, we never actually just discuss a hypothesis alone. In statistics, we're always wanting to test things, and so we talk about hypotheses in pairs. And the two hypotheses are called the null and alternative hypotheses. Okay. Now, some clarifying notes on these. The null hypothesis represents the commonly held belief. Okay, so if we're talking about body temperature, I'm going to use mu for average body temperature. Okay, mu is average body temperature. We know that in humans that the average body temperature is, at least in Fahrenheit, 98, 98.6 degrees Fahrenheit. Okay. And so we would say that this is the commonly held belief, and so this would be our null hypothesis. Now, in terms of notation, we always denote the null hypothesis with H with a subscript of 0. So HO, or H0, okay? And then we do a colon, and there we go. I should maybe move that over just a little bit for formatting purposes, but that would be your null hypothesis. Now, you can also express the same thing in words, okay? And you will need to be able to do both. Okay, the alternative hypothesis is what the new idea is. So maybe after, doing extensive measuring among your friends or some group of people, you think, nah, people are actually colder than that. Maybe they're just cold-hearted, and you think, oh yeah, that's why their body temperature is lower. So then maybe you're saying that maybe their body temperature is lower, or the average body temperature is lower than 98.6 degrees Fahrenheit. Okay, and so that would be, oh, I should actually label this as H1 for your alternative. So alternative you label as H1. Okay, so those are your two individual hypotheses, and together they form a hypothesis test. And you'll see why we call it a hypothesis test later on. But you are welcome to fill out, just pause the video and describe in your own words what is a null and alternative hypothesis. I encourage you to do that. Okay, now some final notes here. It has been long debated among mathematicians and statisticians the relationship between null and alternative. Okay, some take a complementary view, and so what that means is that instead of this being equals, if this is greater than or less than, this would be greater than or equal to. Okay, some people are very strong for that. Other people just say, nah, it's just going to be equals. Okay, so then there's no definitive answer. We're going to take the view of equals in the null for this course. Okay, just so we're all clear. Okay. My suggestion when you're writing out the two hypotheses, because you always need a null and alternative hypothesis in every hypothesis test. Okay. You should write the alternative first because that's the new idea, and then the null becomes a little bit easier to write because it's just this value or this parameter equals this value. Okay. When we talk about hypothesis tests, we also talk about this idea of Sideness. And so what the Sideness is determined exclusively by the alternative hypothesis. And so we get one side to the left if the alternative is less than, okay? So left, less, and it's going to be one side to the right if the alternative hypothesis states that the actual value of the parameter is more than, so greater than, okay? Right is greater than, and then two-sided is just different from. So if we look at the little fictitious example that I did up here, in the alternative hypothesis, I notice that I have less than, so consequently, this hypothesis test that I just made up is going to be one-sided to the left, okay? So, and there should be, you should be able to determine the Sideness in every hypothesis test. Okay, so in this video we talked about hypotheses and how they always have to include a population and a parameter. I didn't here, I should say among, now that I think about this, I should U.S. citizens. Okay. So you should always clarify your hypotheses so that they have population and parameter every time. Okay, and then we talked about null and alternative hypothesis, and then the Sideness. Okay, so we will get some practice with this in the next video.